All right, so I finished my general announcements, the very quick overview. CFU number 9 was passed back yesterday. It's retakeable until Monday the 16th. CFU 10 is due today. Students have 2 days to get that in for late credit. That's 10% off. It'll be passed back on Friday, this Friday, which is the 13th. You'll have until the 20th to retake that. CFU number 11 is going to be given in class today. Anyone who's absent has Wednesday and Thursday to make it up. It'll be passed back Friday. You'll have until the following Friday to retake that. So there are a lot of retake deadlines that are coming up. One other CFU left, which is this Friday. And fair warning, that one will not be passed back until the following week, but I'm looking for retakes to be done by Friday the 20th. I'm not looking for people to retake that after winter break. Okay? Students were already given a couple minutes to complete the multiplication at the top of page 13. And as I explained, the plan for today, I'm going to go through 2 full problems, this being one of them, and then give students time to do 2 other full problems themselves, and then we'll move to CFU 11. But the bottom line is, if you can do what we're doing in class today, you should be fine on the CFU. I gave people 12 minutes. One student turned it in last period in 3.5 minutes. So if you're paying attention, you know what you're doing, you can get it done way faster than 12 minutes. All right, create a table for the function f of x equals 10 to the x. Then create a table for the inverse function f inverse of x is equal to log x. Then graph and describe the properties of f inverse of x. So please notice that all of this and all of this is going to be based off of the inverse function only. If you read the directions, you're not graphing the regular function. You're only graphing the inverse function. But it helps to get the points of the original function in order to create the other table. I'll show you what I'm talking about. So I want to type f of x equals 10 to the x in my calculator. Now, I have no idea what I did with this calculator in the last period. I can see there's already some stuff in it. I can see there's something typed there. So I'm going to reset my calculator. 2nd plus 712. I'd encourage you to follow along now. I would encourage you to reset your calculator and follow along with me. Type what I type. Mr. Landon, if you wouldn't mind, sir, I appreciate it. I'm going to do y equals and type 10 raised to the x. Now, we are not graphing this one. So this is one of the rare situations where I'm not going to look at the graph. There's no reason to. All I need is to fill in this first table with the values at -2, -1, 0, 1, and 2. So I'm going to go straight to the table. I'm going to go up so I can see -2. And these are the values I'm going to copy. 0.01, 0.1, 1, 10, and 100. That's what I'm going to copy into this table. Now, believe it or not, just getting that gives you everything you need, bless you, to be able to do the rest of this problem. If you want to create the table for the inverse function, take these columns, flip them. So I can literally just copy the values, but I'm just going to flip them. Now, those points are going to enable me to graph the inverse function. This is what we want to graph. And we're going to use this table to do it. Now, of those 5 points, one of them you can't even graph. It's way off the chart. 100, 2. You can't even graph that, so don't worry about it. 2 of the points I expect to be perfect. 10, 1 should be graphed perfectly. 1, 0 should be graphed perfectly. But the other 2 points just need to be reasonably close. Okay, for example, the point 0.1, -1, that's like barely to the right and then down 1. So that's going to look something like that. And then the next point, 0.01, -2. Well, 0.01 is so barely to the right that it basically looks like it's on the y-axis. Okay. Now, if you're looking at those 4 points and you're not really sure, well, how should I be drawing the graph? What I would recommend is take a moment and type the inverse function into your calculator and look at the graph. That way you can see the thing that you're supposed to be creating here. So I'm going to go back to y equals. I'm going to clear that equation out, hit the clear key, and type log of x. And now I get to see the thing that I'm trying to create. And now it makes sense to me. All right, it's this curve that just shoots to the right really fast. You'll notice that it looks like it disappears when it gets close to the y-axis. That's a signal that there is a vertical asymptote there. We've seen many examples like that already. Okay, it looks like the curve basically disappears, and that's because there's a vertical asymptote along the y-axis. So now I know, okay, I'm going to want a vertical asymptote here, and I know I'm going to draw this curve shooting to the right very quickly, and the other piece of it just basically goes straight down along that asymptote. This now allows me to answer all of these properties. I already mentioned there's a vertical asymptote that hits the x-axis at 0. For the domain, remember domain is how far left and right this function goes. You'll notice that the function can go to the right forever, but it cannot go left forever. It gets trapped by that asymptote and it just kind of goes down. It can't keep going to the left. It gets trapped. So the furthest left it reaches is 0. The furthest right it reaches is positive infinity. So that is your domain, 0 to infinity. Your range is how far up and down this thing can go. Well, this side, as it goes to the right, it also keeps going up. So it just goes up forever. It goes up very slowly, but it is going up forever. And on the left side, it's going down forever. It just keeps going down, 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 down. So it turns out the range is all real numbers. It goes up forever. It goes down forever. So negative infinity to positive infinity. And for those of you who prefer the real number symbol, if you just write that symbol, that means negative to positive infinity. Now, just like every other logarithmic equation we've seen so far, this one is always increasing. If you imagine hopping on this thing and riding it to the right, it is always going up. So I would literally just copy my domain. Whatever you wrote for the domain, just copy it and write that same thing for the increasing interval because it's always increasing. There is no decreasing interval. Now, the last bullet point is x or y intercept. Which axis does this thing never touch? That's my first question of the day. See if people are paying attention. The y-axis, you got it. We've got a vertical asymptote right there on the y-axis. It gets really, 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 really close to the y-axis as it goes down, but it never actually touches it. So it does not go through the y-axis. You don't have to X that out. In fact, I'll highlight it in red. Okay, it doesn't go through the y-axis, but it absolutely goes through the x-axis. Okay, let's use green for that. Right there. Okay, and that coordinate pair is at 1, 0. That, in a nutshell, is what your CFU looks like today. It's going to be a problem where I give you a function, you have to use that function to fill in a table, and then you can use that table to do everything else. You can use that table to build the table for the inverse. You can use the inverse points to build the graph. You can use the graph to answer the property questions. But I'm going to do one more before I give you all a chance to practice one yourselves. All right, go ahead and turn the page. As I said, I'll do one more. This is the top of page 14. It says, create a table for the function f of x equals e to the x. Then create a table for the inverse, f inverse of x equals natural log of x. Then graph and describe the properties of f inverse. So once again, we are going to use these points to create the graph and answer these properties, because that is what we're being told to do. Do all this stuff for the inverse function. But to get there, I'm going to use the regular function to fill in the original table first. Okay, so I'm going to do this first, and then I can use that to do everything else. That's the idea. Okay, so I go to my calculator. Again, I'm going to reset it just to get rid of all the other stuff I've already done. Second plus 712. Reset my calculator. Go to y equals. I hit E, which is the connected to the division key. So I hit second and then division raised to the x. Now, because we are not graphing this one, I'm not going to bother hitting graph. I just need the table of values starting at -2. So I'm going to go to table. Gentlemen, you good? If you have questions, let me know. Landon, Urim, you good? All right. So I'm going to jump back to -2. Remember, for the purposes of graphing, I said it's totally fine to give me 1 decimal. Okay. I am going to round though. Like this one, I'll call 0.1. That doesn't need to be rounded, but that one should be rounded up because the 3 is followed by a 6. So I'm going to call that 0.4. This is 1. The 7 is followed by 1. So I'll just call that 2.7. But that 3 is followed by an 8. So I'm going to call it 7.4. So I end up rounding 2 of those values. Now, once you have those values to create the inverse, once again, all you do is take the table and flip them. I'm going to take those points and I'm going to flip them. And those are the values that I want to graph. Now, of those 5 numbers, the only one that I would expect to be perfect is 1, 0. All the other points involve decimals, so they just need to be reasonably close. For example, 2.7 comma 1. It's close to 3, but it's not quite at 3. 7.4 comma 2 is basically halfway between 7 and 8. The other two are a little weirder. We got 0.4 and -1, and 0.1 and -2. Now, I can already immediately see the curve. I'm sure some of you can as well. Okay, we're going to have this curve that kind of shoots to the right, and then it shoots down, and we've got a vertical asymptote at x equals 0 again. But again, if you want to know what is this supposed to look like, go ahead and type that into your calculator. Okay? So let me go to my calculator. I'm going to type natural log of x. So I go to y equals. I'm going to clear out that because I'm done with it and type natural log of x. And if I hit graph, I can see the thing that we're trying to create. And once again, I know that it looks like it disappears up against the y-axis, but that's because the calculator has trouble displaying vertical asymptotes. Okay? So I've got one piece that shoots off to the right. Got this other piece that kind of just arcs down and hovers by the y-axis because we have a vertical asymptote there. So once again, vertical asymptote is at x equals 0. Once again, we have a situation where it goes right forever. It does not go left forever. It goes up and down forever. It's always increasing. So I'm just going to copy my domain. Whatever number you have here, I'm just going to copy it down here because it's literally always increasing. It is never decreasing. And once again, there is no y-intercept. It never touches the y-axis, but it absolutely hits the x-axis right there at 1, 0. Okay. Questions? All right, so I finished problem number 2. I just gave students time to complete problems 3 and 4, posted the answer key, gave a chance to ask questions, and now we're going to move to the CFU. That's what will take up the remainder of the period. Thanks for watching. Have a good one.